Hello friends, welcome to SQL Server tutorial. Now we are starting a new sub-series, and in this sub-series we will learn about database snapshots. In this first video we will get introduced to database snapshot. A database snapshot is a view of the entire database taken at a specific point in time. Let's state that this is the time span, and during this time, let's state that this is a different time interval, day, week. You can consider whatever you want. And during this time span, database will undergo some changes. A table will get inserted with records, or a table will get modified. A new view may be created, or a new procedure will be created, or some procedure may be deleted, or some records in the table will be deleted. So those are all the changes that will undergo on a database when time spans. So at a given point in time, we can take a snapshot. We can take a snapshot so that in a later point in time, you can restore that snapshot. So that's the purpose of a database snapshot. A database snapshot is a view of the entire database taken at a specific point in time. So this is different from database backup. Snapshot presents you the read-only database. So once you take a database snapshot, the snapshot is read-only. You cannot modify the snapshot DB. This read-only database is useful to analyze the data and to generate the reports. So state that at a specific restore point, we named this snapshot as snapshot 1, and this will have records and other details, database objects. So this can be used, this is a read-only database, right? It can be used to analyze the data, right? Because it's a fixed data, right? So you no need to worry that the data will change at a given point in time. The data is taken or snapshot is taken. You can analyze, even generate the report. So the data will not change. Since it's a read only, the snapshot at a given point in time is taken and it is read only. From this read only, you can do the analysis without worrying about the data will change over a period, or you can generate the report because it's a fixed data and it's read only. It's also useful to recover from error caused by end user and perform administrative tasks. So all those stuffs are applicable with read-only database or the snapshot. So if some problem happened, we can restore it to the previously taken snapshot point in time. So usually people will prefer backup, but it's also possible to revert the database to the time in which the snapshot was taken. Recovering means a database can be restored to a previous snapshot. So the advantage of snapshot is taking snapshot is quick and easy. One can take multiple snapshots and analyze the data. That means in a different point in time, a person can take multiple snapshots. So generate reports from snapshot so that source database is not disturbed. So when you are generating the report or doing the analysis, you are doing that on the snapshot, and since you are not touching the source, the load is on the snapshot. recover from the data and perform administration error or administrative task that performs error recovery. So here you can revert the database to the source snapshot. So here you can recover the database to the snapshot. So source database you can recover to a snapshot. We know that this is the source database. You can take snapshot at a different interval and you can revert the source database to any snapshot. Limitation is taking snapshot occupies disk space. Performance hit has page modification moves data from source to destination. So we will see that in more detail in the next page. You will get a clear picture of why it's a performance hit and what is meant by page modification moves data from source to destination. When snapshot exists, the source database cannot be dropped or detached. So based on the source database only a snapshot exists. So when there are snapshots like this, if you see here in this picture, there are two snapshots. So this is your main DB. When snapshot exists, you cannot drop the database, or you can even you cannot even detach the database. When multiple snapshots exist during the restore period, all should be dropped except the one that acts as a restore point. So if this is the main database which undergoes changes, let's state there are multiple snapshots, and from a specific point in a database, if you want to move to a specific snapshot, and let us state that you want to move to snapshot 2, then you have to drop other snapshots and you can move to a specific snapshot. When multiple snapshots exist during the restore period, all should be dropped except the one that acts as a restore point. So if you decide S2 as the restore point, then you have to drop other snapshots. So that's one limitation. Snapshots are read only, which cannot be detached. So we already know that snapshot is read only, so a snapshot cannot be detached. When there are multiple snapshots, DML operation goes through a performance overhead. So we already know that performance hit has page modification moves data from source to destination. Whenever you modify the data, there will be data movement from source database to the snapshot pages. So if there are multiple snapshots, then that movement occurs for all the snapshots. Here if you see, since there are 4 snapshots, and if you modify or make some changes, then there will be data movement from main to these restore points. So these data movements will help to restore the database to a specific snapshot at a later stage. So that's the purpose of a snapshot, but this data movement may be a performance hit, especially when there are multiple snapshots. Taking snapshot is quick and easy. We already know that because there is a data movement at the start. Upcoming DML delta changes are recorded for restore purpose. Let's see how. So now let's consider that we have taken one snapshot, and after taking the snapshot, there are 2 entities. One is the source DB and another one is a snapshot. So snapshot will be initially entry. That's why while you are taking snapshot, it won't take much time. So the snapshot will get created immediately. Then after that, let's state that in source DB, there will be some modification. let's state that in a specific table some records are deleted, or some set of data are modified. So these are all the data pages. When a page is modified, what happens? We already took a snapshot, right? The original data moves to the snapshot. So the source DB contains modified data, and unmodified data, or the page without any modification, will move to will move to the snapshot. So now if you see, the snapshot has the original version of the data, right? Here it is modified and here it is original. Let's state that in one more table, let's say deletion. So the table is modified because some records are removed. So it moves the initial data to the snapshot and then performs the delete operation. So at later stage, when you want to restore the data, what happens is, since it preserves the initial data, it will replace this modified content with this backup initial data. So this is what we are calling it as a data movement on each DML. So that takes time or a performance hit. Whenever you modify, it needs to preserve the original content in the snapshot, and if there are multiple snapshots, such movement occurs to different snapshots, right? So that's how the restore can be performed at later stage. When you ask for restore, it will replace the modified content with the initial content. That way the database will be restored. That's all here in this video. Thank you for watching. Bye.